I'm NASA astronaut Jessica Meir. I may be one of the first people to return to the moon. The Artemis mission has this stated goal of sending the first woman and the first person of color to the surface of the moon. It will have been over 50 years since humans have set foot there. We aren't just going to go there once and then come back, or go there a few times like in the Apollo missions and then come back. We're going to keep this presence going with a gateway program that will be an outpost in orbit around the moon. Think of it kind of like a little mini space station with subsequent missions of landings on the moon, and then eventually using all of that time and knowledge in those lunar missions as a springboard to go even further and go to Mars. My mom tells me I first started saying I wanted to be an astronaut when I was 5 years old, so it actually was quite difficult to believe when it came true in 2013 when the phone rang and I was given the option to come here to NASA to be an astronaut. It's almost felt surreal.
Copy, Jessica is egressing, 10 seconds to a 20-second handover.
Coming out of the hatch for your first spacewalk is a moment that I don't think anyone ever forgets. My first spacewalk happened to be only a few weeks after I arrived on the space station. So at that point, I was still learning how to move and navigate myself around on the space station. That day, I was with my colleague and friend, Christina Cook. She was in the same class of astronauts as me, so we really are like astronaut siblings. She's like my space sister. We were ready to go out of the hatch that day for the first all-female spacewalk. Of course, there had been other women that had done spacewalks before us. We were the 14th and 15th women to do so, but this was the first time that two women together were going to embark on a spacewalk. So there I am, and I'm looking down at my feet, dangling below the hatch, and then there is nothing else between this Earth spinning below and my feet. And that was just the most profound moment. I was just in awe and so excited. Just us up there. We're floating the whole time, going around our planet every 90 minutes. It was still, even though I was living it, even though I understood the science behind why I was there, it was still difficult to believe that it was actually happening. So it was really only after the spacewalk ended that I started thinking more about what it meant. And it was interesting because in the beginning I thought, why does it matter? Why is there so much attention being drawn to this first all-female spacewalk? It just happens to be the fact that right now there are two women going out the door. We're just as qualified as everybody else up here, and so it's just a matter of time that this would happen. But then when I started thinking about it differently, so many people tuned in to watch that spacewalk, and so many people started giving us this feedback about how inspiring it was for them and how much it meant for them. And that really took me a little bit by surprise. And I also started thinking more about the generations that came before us. So Christina and I, both of us, when we look at this now, we don't think about it as our personal achievement. We had that opportunity because of the generations of women and other minorities that had worked so hard, that had truly pushed the envelope and broken those glass ceilings to allow us to be where we were. So now, when we look toward the future and we look at the Artemis program, this administration has set forth the goal that we will be sending the first woman and the first person of color to the surface of the moon. Of course, I would be absolutely thrilled to be that person, to be one of these first people returning to the moon. And to me, it would represent so much. I know somebody asked me once what I would say, what would be those first words, like we have those famous first words from the Apollo mission. And that is something I would have to put a lot of thought into. I think to me it would be a little bit like how I described that first all-female spacewalk. It wouldn't be about my achievement. It would be about the achievement of everybody on this NASA team that got there. And it wouldn't even only be limited to that. Really, that next person that goes to the moon is a representative of all of humanity. So a lot of people ask us, why haven't we been back to the moon? If we did this 50 years ago, why is it so difficult? Why haven't we been doing it? There's nothing easy about going to the moon. What we accomplished in the 60s was extraordinary. We are due to go back to the moon for so many reasons. The first is simply for exploration. It is an inherent characteristic inside us as humans to explore, to want to look around the corner, to go further, to ask those questions and just quench that curiosity that we have. Secondly, though, and equally as important, is for scientific reasons. If we look back at the Apollo missions, we learned so much about our solar system, about the formation of our planet and of the moon, and I know that that will be true as well for the Artemis missions. For example, we'll be targeting the South Pole because at that area, we know that there is much more frozen water. So by going to that spot, we can study and understand that water, that ice, that frozen water will help us understand more about the moon, about our solar system, and it will also be a resource we can use. Oxygen in the soil, we can use that frozen water in the surface, we can use that to make fuel, to make resources for further exploration. So that would be that next step. Take what we learn in the proving ground around the moon and now use that to get to Mars, where we need to be autonomous. We need to think about things like sustainable food systems. We won't even be able to necessarily carry all the food and water that we need up there. So maybe we want to bring some things that we can grow. Everything that we learn in these early Artemis missions to the moon will apply then on to Mars. Fairly soon, we will be launching that Artemis 1 test mission, and that mission will be about 3 weeks. It will go all the way out to the moon and beyond it, and we will test out all of those systems of the Orion spacecraft and that launch system. The next mission, the Artemis 2 mission, would have crew members on it. So that will be the first mission that has astronauts going out to the moon. They won't yet land on the surface of the moon, but they will go out again further than the moon. They will be in orbit around the moon before they come back here. So that will be another vital step in making sure we have everything ready and we're prepared for those later missions, which will then land on the surface of the moon. We'll also have the Gateway, which will be in orbit around the moon. So think of it kind of like a little mini space station. Instead of being around the Earth, though, it'll be there proximal to the moon. And then we can use that to go back and forth. We can keep people on board the Gateway, and then we can have regular excursions down to the surface of the moon. We can use that as a test bed for other hardware and technology and experiments. And then we can eventually use that as a stepping stone to getting to Mars. To me, the moon represents this spirit of exploration that I think has driven humans from the beginning of evolution of our species, and also me personally. The stars, the Milky Way, the moon were so bright in our view, and I think that's something that really shaped part of my childhood, letting that natural scientific curiosity, that spirit of exploration, extend not only from what was in front of me on the ground, but also to what was lying up there above. And of course, the moon is this incredibly prominent object and something that I think we're all drawn to. It makes me so optimistic now to know that it is a national priority again. We have laid out this foundation to get back to the moon, so we will return.
You waited years for this!
I waited years!
This was almost the perfect day. Almost.
Rosetta was and is a unique space mission.
It's a travel not just in space, it's also a travel back in time to the very early days of the solar system.
This is the story of the epic, ambitious mission to land a spacecraft on a comet hurtling through space. Nothing like it had ever been attempted before or since.
Rosetta completely transformed our view of comets.
It was a mission 25 years in the making that all came down to a few frantic hours.
Philae was not anchored.
It bounced. We don't know where it is.
But let's go back a bit to 2004. The Rosetta spacecraft, with its little Philae lander tucked away inside, is about to launch.
3, 2, unité. Top, à l'image EAP, décollage.
Well, the actual launch took place on 2nd of March in 2004.
The first part of the mission was just to catch up with the mysterious comet, known as 67P. That took 10 years, during which time everything on board Rosetta was powered down, only to be woken up as it neared the comet.
It was quite a nervous time when Rosetta was coming out of hibernation.
Because if it didn't wake up, that was curtains, really.
Billion euros of kit out in space, and if it didn't call home at the expected time, there was very little that could be done about it.
And then it got this signal, wake up Rosetta, and it's just like, hasn't woken up. All right, send the signal again. Switch it off and switch it on again. Ta-da! It's woken up, which was just so much of a relief.
Hurdle 1 out the way.
When Rosetta woke up, that was really the point where everybody got excited again. We had no idea how the comet would look like.
We don't know what shape it is. It's probably spherical-ish.
We didn't immediately see the high quality images. We saw better and better ones the closer and closer Rosetta came.
Then, wow, what shape is that?
The shape is not potato-shaped as we expected, not roundish. It's
The comet has this kind of rubber duck shape.
It's like one of those yellow plastic ducks.
And that made hurdle 2 that extra bit harder, landing Philae safely on top of it.
There was no area on this comet which is nice and smooth as we have hoped for. The terrain was rough everywhere. So there was a risk, but that also made it fascinating and interesting.
Philae was equipped with little harpoons to fire off to help it cling to the comet once it made contact. And the landing site had to be meticulously chosen to allow Philae to recharge its solar batteries in the glow of the sun. The stakes were huge. This was a lifetime's work for most of the scientists on the Rosetta mission. The team already knew there may be a problem with the thrusters that were supposed to slow down Philae's approach, but the time had come to deploy Philae. And on the 12th of November 2014, off it went.
One could see the Philae lander as it moves away from the main spacecraft, getting smaller and smaller with the landing gear successfully deployed. I found this already very emotional to see the baby go after 10 years attached to the spacecraft. You now see it in freedom on its way the last 22 kilometers to the surface of the comet. And then Philae was free falling for almost exactly 7 hours to the surface of the comet.
Everybody was, jittery and just waiting and waiting and waiting for the signal to say it had landed.
And then
I just went absolutely, hey, it's landed, I'm so excited, it's landed. It was just the tension that had wound up and the release of that tension and the relief.
We've waited years for this.
I waited years. I'm just so excited. I'm gonna cry. I'm sorry. It's fantastic.
And of course, everywhere in the world, in the control rooms, in the scientific teams, people started to open the champagne and started to celebrate.
It landed. It was fantastic. It was wonderful. Everybody was really, really, really happy.
In the control room, we thought, yeah, great, we are landed, we have the touchdown signal.
But the mood in the control room was suddenly very different. Something wasn't quite right.
Within a few minutes, we realized that although we have landed and although we still got radio contact, which was positive, we did not anchor and the lander was moving again.
And then the principal investigators came out of their little cocoon and Ian came up to me and he gave me a big hug and I gave him a big hug and I said, it's fantastic, isn't it? It's really great, you must be so proud and pleased. And he said, no, it has gone wrong. It bounced. We don't know where it is. I said, what do you mean? He said, well, it hasn't been announced yet, but it will be announced in a minute that actually Philae did land, but the harpoon didn't anchor it and the little crampons on the legs couldn't get a grip. And so it's bounced.
And we had no idea what's going on, where we would jump and how we would land and when we would land.
Oh dear.
Philae had crashed off the face of the comet and bounced about 1 kilometre back into space. Any further, and it risked escaping the comet's weak gravitational pull and drifting off into space forever. Anxiously, they waited.
We had no idea whether this would be a successful mission or would be just a touch and we would never again hear from the landers.
And then the news came in.
So we did land somewhere and we still had radio contact. We still received signals, and this was the moment of great relief, because that was the moment where we knew we are at the surface and we can still communicate with the lander.
But the good news didn't last long. It landed in the shade. Not great for something reliant on solar power. This meant they had less than 72 hours of battery time to undertake months' worth of scientific collection. The clock was ticking.
So it's one of those things, it's like, okay, let's just throw away 10 years worth of calculations and let's just redo them all over the space of 5 hours, which is what they did.
We also optimized the sequence in a way to get the maximum science out of the energy available.
Once they knew they'd only got 70 hours, and it was just going to seep away, it's like it wasn't if you turned all the instruments off, the battery would stay at that particular level. No, because it was so cold, it was having to maintain, it was having to keep heaters on as well, you know, to make sure that the instruments kept working. So you just knew you'd got 70 hours full stop, all right? So you worked for 70 hours. You just did it. You just barreled through, get as much data as we can.
And amazingly, almost all of the instruments on Philae had survived the impact. It was go time.
We were very lucky. I mean, we ended up in an orientation that the antennae were pointing, upward, so to say, that we could establish the radio link with the main spacecraft. And again, we were also lucky because we could switch on the instruments. We could do fantastic science from the surface of the comet.
About 80% of the science goals of the Philae lander were achieved. So it was an absolute fantastic success. You know, the fact it crash landed, got around that. It was an amazing success.
This was, of course, a bit sad to see the voltage of the battery drop and knowing that Philae will go into a hibernation.
And eventually, that's what happened. But even in those few hours, Philae had unveiled a world full of surprises. Of dust and debris, gases erupted from deep within the comet. Even the crash landing threw up interesting discoveries.
Even by analyzing the bounce itself, we got information on what's the surface made of. And it was a bit surprising that the surface was rather hard.
But perhaps most exciting of all was what this comet was able to teach us about us.
The Rosetta mission had as one of its goals to understand the building blocks of life.
Because Comet 67P was rich in organic compounds like phosphorus, carbon, oxygen, nitrogen, and the amino acid glycine, all essential for the origins of life, and offering tantalizing clues as to how these compounds may have arrived on Earth in the first place.
So the original building blocks of life came from comets.
While Philae had gone into eternal hibernation, the mothership Rosetta continued to fly around the comet, collecting data for 2 more years. But then, Rosetta's time had to come. In a last-ditch effort to get as much out of the mission as possible, the team decided to crash land Rosetta into the comet, collecting data along the way and allowing the scientists to get one last look at their old friend Philae.
Took this sort of shallow dive onto the surface of the comet and then sort of crash landed, and its camera was going the whole time. So we saw these last pictures of the surface rushing up to greet Rosetta. And then the signal died, and you got this little sort of oscilloscope thing with nothing on it. Just like, you know, like somebody when they die and you see the signal die on the heart thing. And it was just like, it was It was so devastating. People were in tears. I cried. And it's just hell's teeth. It's a robot, you know. But it's been part of your life for so long and so important. So that was it. That was the end of the Rosetta mission.
There is still many publications done using the data from Rosetta. That's still the most relevant and best scientific information we have from a comet.
Rosetta completely transformed our view of comets.
To some extent, what we know about the evolution of the solar system and what we believe about the formation of life, all of this is triggered by Rosetta, and this is not often in lifetime you get a chance to get involved in such a project.
Like Jess Barnes, geologist Katie Joy is fascinated by the far side mystery.
Because people hadn't seen the far side of the moon, we just made the assumption that the far side was the same as the near side. So Luna 3 turned our ideas on its head, and those ideas are still being turned on their head.
Katie is one of NASA's lead investigators, studying the precious Apollo samples to better understand the moon's mysterious past.
Because the moon's surface is very old, it can tell us a lot about history of the solar system's past. It can tell us about Mars, Mercury, Venus, and the Earth. Every time there's new technology, we can ask these rocks new questions, and that's why they're sort of the gift that keeps on giving, because they're always going to be available for us to look at with new ideas.
The Apollo samples continue to teach us about the moon, the Earth, and the rest of the solar system. But when it comes to solving the far side mystery, there's a problem.
With the lunar missions that have been to the surface and collected samples, we've only visited a very geologically restricted area on the near side of the moon. So in order to fully understand the moon and the far side composition, we really need to go back and collect samples from a more diverse region.
And with NASA's Artemis mission, aiming to return humans to the lunar surface in the coming years, Jess is preparing for a new batch of evidence.
We want to preserve that DNA, fingerprints, rocks as precisely as possible so that we don't lose any of that evidence. So before we go back to the moon, we really need to understand what's the best way to curate and keep samples safe and preserve them for future generations.
To get ready for these upcoming missions, NASA is releasing some crucial, untouched evidence from its vaults.
After Apollo 17, people soon realized that it would be beneficial to future generations to lock some of the Apollo samples away in special storage for 50 years. And now we're at the point in time when NASA has decided things have improved so much that we're now at a position to open those samples, use new technologies on them to answer past and new questions.
Now, armed with techniques impossible 50 years ago, Jess is one of the handful of people chosen by NASA to analyze these precious samples.
One of the things that we've been doing is using a particle accelerator to measure the oxidation state of sulfur in our samples. We're really looking at these samples forensically, and this is a really new technique that's been applied to lunar samples only in the last few years. So yeah, bring it up a little bit and we can do a slow scan.
This tool allows Jess to piece together the sample's history and establish how new evidence might be better preserved in the future.
We find that samples that were prepared 50 years ago contain a lot more sulfur than we see in samples that were actually stored frozen for 50 years. We're not quite sure why that is, but this is one of the things that we want to find out. Do we need to do something differently for samples coming back from the moon in the future?
It's a problem that must be addressed before we return for more evidence. Something Jess knows is critical if we're ever to finally solve the mystery of the moon's far side. In 1996, scientists announced they'd found evidence of possible Martian life. But Mars is a frozen desert planet, its surface is completely uninhabitable. So could these strange shapes really be ancient alien fossils?
Release and liftoff.
And why do scientists think they might be able to find more of them?
I've always loved space. There's all kinds of things moving around, and we have no idea what's out there.
Planetary scientist Nina Lanza knows it can be difficult to interpret images from space.
This is Percival Lowell, who was an astronomer in the 1880s who was obsessed with Mars. He made many observations of the surface of Mars using telescopes on the ground on Earth.
Lowell's maps of Mars led to an idea that has enthralled us ever since.
What he thought he saw were these canal features. He thought he could see signs of a civilization on the surface of Mars. And these ideas had a huge impact, not just on science fiction, but also actual science.
So in 1964, when NASA's pioneering Mariner 4 probe reached the Red Planet, the public eagerly awaited their first look at the alien world.
Mariner 4 was the very first time we had close-up images of Mars from a spacecraft. People, when they first saw them, were incredibly disappointed because they looked nothing like the Mars of our imagination. There were no alien civilizations, there was no water, there were just a bunch of craters, and it really looked like the moon.
But just 7 years later, Mariner 9 made scientists think again. Its more powerful camera revealed something remarkable etched on the Martian surface.
This is an image from Mariner 9, and it's a really important image because it was the first time scientists saw evidence that there might be something more on the surface than just craters. This is a very sinuous channel that looks like it was carved by flowing water.
Each mission that followed has unearthed more evidence that Mars was not always a dry, frozen planet.
The Viking orbiter sent back some incredibly beautiful images, things like these flowing channels and teardrop islands, both of which suggest that water was once abundant on the surface and flowing, making these features. Mars Global Surveyor sent back this one, which shows a feature that looks like a beautiful river delta. The twin rovers Spirit and Opportunity found dramatic evidence. These are hematite spheres, and they form in water. This is a vein of a mineral called gypsum. So gypsum is a mineral that not only forms in water, but actually contains water in its structure.
It's now known that in the first 1 or 2 billion years of its life, Mars was much more like Earth. It had a thick atmosphere and was covered in rivers, lakes, and seas.
There is overwhelming evidence, just looking at the surface, that there was a lot of liquid water on Mars's surface in the past.
However, this discovery, while extraordinary, did not prove Mars also had life.
Life needs water, but that's only one thing that it needs. It also needs certain chemical ingredients and also environmental conditions before it can actually develop and thrive.
The northern lights on Jupiter are the most spectacular in our solar system. They're stunning, and they're bigger than our entire planet. They produce incredibly powerful flares that reach terawatts of power. That's more energy than you'd need to briefly supply all of human civilization. What causes them? Why do they seem to pulse like clockwork? To truly unlock Jupiter's mysteries, we needed a way to get closer to it than ever before.
Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. We had to, build an armored tank to go there.
Juno arrived in Jupiter's orbit in 2016. As it got closer, the auroras on Jupiter became so dramatic and active that astronomers said it was like Jupiter was putting on a fireworks display for Juno's arrival. which seems apt given the sheer scale of the spacecraft.
Behind me is the Juno spacecraft, basically life-size. It's an enormous spacecraft, close to 70 feet in diameter as it spins around and cartwheels through space. This is one of the largest spacecraft ever made.
Juno showed us more than we'd ever seen of Jupiter's auroras as they rippled over the planet's poles. The northern lights on Earth are caused by solar winds entering our atmosphere and interacting with the planet's magnetic field. Jupiter's magnetic field, also known as the magnetosphere, is 20,000 times stronger than the one here on Earth.
It extends all the way back to Saturn and perhaps further. And it's the biggest structure in the solar system next to the sun's magnetosphere.
That's one of the reasons Jupiter's auroras are so huge. These gigantic magnetic tentacles capture particles from across the solar system, thrusting them towards the planet's poles, creating this epic light show that never dies. But this is only part of the story. As well as photographing Jupiter's dazzling displays, Juno also began mapping Jupiter's core. And that's when things got interesting. Jupiter is a gas giant. It is full of loads of gas, especially hydrogen and helium. And when hydrogen is under extreme pressure, it acts in a really weird way. It becomes liquid metal. Liquid metal! Like at the core of Jupiter is an ocean of liquid metallic hydrogen. And using some of Juno's findings, physicists in California tried to recreate this extraordinary phenomenon, bubbling away deep inside Jupiter's core.
So basically we are creating a little planet interior inside our laboratory.
Marius Mio and his team at the National Ignition Facility conducted a pretty crazy experiment. They fired lasers at a tiny target, which imitates the core of Jupiter. The lasers simulate the unfathomable pressures going on inside.
So this is the target that we put inside this target chamber. We fill a little portion inside this cone here with liquid hydrogen, about 20 millionths of a gram, and then we shine 80 laser beams from the top and 80 laser beams from the bottom. So the power that we put in the lasers when we shine the laser onto the target is about 500 times the power that is used for the entire United States at a given moment.
T-minus 5, 4, 3, 2, 1, shot.
Through the laser blast, the team observed this surreal change that takes place in the core of Jupiter.
At this time, the pressure got so high that the light is now reflecting off the shiny surface of the hydrogen. Hydrogen transforms from being transparent to opaque and then becomes a metal, like a shiny metal. If we were to go deep inside Jupiter, we would see a deep ocean of fluid, shiny metal.
And just like that, the planet completely messed with what's possible with the elements. It throws out the rulebook. On Jupiter, this metallic hydrogen makes up to potentially 50% of the planet's mass. And it's this huge liquid metal ocean that accounts for Jupiter's gigantic magnetic field. But that's not all. It also causes charged particles to leak out at its extremities, and it's this that causes the breathtaking auroras that outshine all the others in the solar system. So Jupiter's core is the main source of the auroras, but its moons also wanted to get in on the act, particularly one of the strangest moons in the solar system, Io. This moon is the most volcanically active in the solar system. Its spectacular volcanoes spew plumes up to 300 miles into the atmosphere, adding extra fuel to Jupiter's light show.
So we see Jupiter in the middle, but around Jupiter we see the moons, Io, Europa, Ganymede, Callisto. The gases that come from Io become trapped in the magnetic field, and they become accelerated to very high energies.
These trapped charged particles get dragged towards Jupiter's poles by its all-encompassing magnetosphere.
Energetic charged particles come in, bombard the atmosphere, make it glow. And then we're seeing this glow in the atmosphere of Jupiter.
So the combination of the gigantic magnetosphere, its supercharged liquid metal core, and unique moons create these breathtaking aurorae. But astrophysicists were still puzzled by one thing. Why do these aurorae light up and flash in semi-regular patterns, pulsing in this extremely bizarre way? It took a team at UCL to crack the case. In the time they watched the auroras, they found that they pulsed every 27 minutes. By closely analysing the data sent back from Juno and the European Space Agency telescope XMM Newton, they came to the conclusion that periodic vibrations crashed across the magnetosphere, causing waves of plasma to send heavy ion particles surfing across the magnetic field toward Jupiter. But the mystery isn't over. Just what causes these vibrations? What determines the pattern of these pulses? And why does Jupiter randomly decide on these rhythmic, regular intervals? This is just the beginning of our learning about Jupiter's auroras. And that's just the start of a wider search. There are more like them across the galaxy, waiting to be explored.
Nearly everything we've sent into space is still there circling our planet. Huge amounts of abandoned old machinery just littering space. It really is a terrifying thought.
When you're going 17,000 miles an hour, it does not take a big piece of debris to ruin your day.
The energy would be more like a 50 caliber Browning machine gun sniper round.
Experts are now beginning to ask, have we trashed space forever? Over the last several years, orbits around Earth have become littered with satellites and old pieces of machinery. So how much junk is in space?
Space junk is all the stuff that we've launched into orbit that no longer serves a useful purpose. So it's satellites, it's rocket bodies, it's old gloves, basically litter that we've left in space.
Now, this isn't a trivial issue because as we enter into a period of more rapid space expansion, from space tourism to companies putting more smaller satellites into space, it's now estimated that the number of pieces of space junk up there is over 130 million pieces that are orbiting the Earth, and that number is only growing. So space is being littered with these dangerous, uncrewed pieces of machinery flying through space at breakneck speeds. It's a lethal accident waiting to happen. So what happens when junk collides?
Copy, Al, you're on your way to the station.
Houston, big loop bag, and I'm going around.
In 2009, NASA actually had to order an emergency evacuation of the International Space Station when they discovered a piece of space junk about the same size as a CD traveling towards them at 8 kilometers a second.
We got a call that we were having a red conjunction, and we're looking around, what the heck is a red conjunction, because we hadn't really trained for it. It was a little bit chaotic because this was the first time we had had one of these.
Copy, Al, you're on your way to the station.
Big loop bag, and I'm going around ESG2.
It's either going to hit or it's not going to hit. And so worrying about it doesn't help you. All you have to do is just prepare everything that you need to prepare so that if it hits, then you're in the best possible configuration.
Now, thankfully, the ISS wasn't hit that time, but this is a genuine concern for NASA, ESA, and other space agencies, because if it was hit, the damage would be catastrophic.
It gets hit by something relatively small, penetrates, but because the pressure inside it just forces the modules to open up, just like a balloon bursting. And that happens extremely quickly, and with no chance that an astronaut in that module could ever get out.
In fact, you can recreate these kind of collisions in a lab, and it really reveals how dangerous they really are.
You see your screen flash up, and it's over. All that work is turned into this. So this piece of modern art here, you can see it's all splayed out. Now that's about 250 milligrams. So that's a little bit bigger than heavier than a ibuprofen pill. And The energy that would have on orbit at, say, 14 kilometers per second would be, well, the momentum would be about the same as a hot-loaded 357 Magnum. So that's a lot of momentum. And the energy would be more like a 50 caliber Browning machine gun sniper round.
A single one of these collisions can create thousands of these tiny lethal fragments that act like space bullets that ripple out into space, causing unimaginable damage as they go. In fact, some forecasts suggest that a major collision like this could happen once every 5 years.
We see thousands and thousands of near misses every single day as a result of all the junk that we put up there. You end up in the situation where, you know, it's basically a lottery in terms of whether or not your satellite is going to be hit.
And this wouldn't just cause issues up in space. With so much of our modern world dependent on satellites for things like navigation and the internet, communications, weather forecasting, it would cause absolute havoc down here on Earth as well. Now, with more and more of these objects being blasted into space every single year, it's becoming a serious threat to modern life. So what can we do about it, and how will we solve this problem? Step one is actually tracking all of this space junk, and that's something that the US Air Force has been doing for decades.
Pre-pass SVN 26.
No time-critical commanding, no satellite conjunction, good on step 6.
They've been cataloguing space junk since the early 80s. They started with 6,000 and have grown to 10,000 over the next 2 decades. And since 2009, the amount of trackable space junk has gone up by 20% to over 25,000 pieces. But the problem is, the only space junk that's trackable is stuff larger than a cricket ball, and it misses those tiny, tiny fragments that can be incredibly lethal. So space agencies across the globe are working round the clock to come up with solutions to remove this space junk. One option, to use a space harpoon.
This system will capture those items of debris, tow them out of the orbits where they might collide with active satellites, and allow them to burn up safely in the atmosphere. So the idea is to have a system which takes them away from where they cause a problem and basically destroy them safely.
It's a great idea, but the thing is, it's a bit of a slow tactic because you have to remove everything piece by piece. And the problem is we're putting even more space junk up there just to do this. Now, other plans include capturing them in a net or sticking a magnetic thruster onto them, or even using solar radiation to sail them off into the sunset. It just shows, though, with so many of these ideas being developed, how dangerous of an issue this actually is. And if our quest to remove this junk fails, and with the increase in objects littering space every single day, the question is, have we ruined space forever?
I want my kids and my kids' kids to be able to explore space. And if we ruin the environment, we can't do that. And that would be tragic, because my passion for space came when I was 10 years old and I watched Apollo 11 and I watched Neil Armstrong walk on the moon. And that magic that created that feeling in me that said, I want to do space. I want my kids and my kids' kids to have that opportunity. And if the space environment is ruined, that'll never happen.
So just like we've seen laws come in to protect our environment here on Earth, we could also see laws come in to help protect space and the environment around Earth, with the hope of preserving the wonder and the beauty of the night sky for generations to come. Now, aliens contacting us might seem like science fiction, but now new mysterious signals from outer space are intriguing scientists around the world.
This signal was so bright that it was completely unlike anything we'd ever seen before.
It's not crazy to think that radio bursts could be created on another planet.
What causes them is one of the biggest mysteries in physics. So are these signals from aliens? Now, linking strange signals from space with aliens sounds a bit like something cooked up by a conspiracy theorist. So is this real science? Yes, this is real science. It's the job of an astrobiologist to figure out where in the universe is habitable and if possibly intelligent life could have developed there and then contacted us. In fact, in 1961, pioneering astronomer Frank Drake organized a now infamous secret meeting to try and figure out how many civilizations like this exist outside of our own.
So we start out with the rate of star formation. Multiply that by the fraction of stars which actually have planets, habitable planets in each system, the fraction on which life develops, the fraction by which intelligence appears, by the fraction of those which actually give a detectable technology. This rate times the average time that these civilizations remain detectable. N equals about 10,000 detectable civilizations at present in our galaxy, the Milky Way.
Calling themselves the Order of the Dolphin, this group of award-winning scientists set out on the hunt for this huge number of civilizations that they thought could be out there.
Oh, I believe very strongly that they are out there. We can be very, very wrong, and yet there will be many, many detectable civilizations.
From secret government agencies to Nobel Prize winning scientists, the search was on for weird, unexplained signals. First, there was the WOW signal in 1977, detected by the Big Ear radio telescope in Ohio.
The signal was strong, about 72 seconds, but more importantly, it was detected in something known as the hydrogen line. That was significant because at the time, astronomers thought that if extraterrestrials did exist, they would use that frequency. The astronomer Jerry Emmon was so excited that he actually wrote the term WOW on the printout.
But very quickly it was dismissed by astronomers as actually coming from a comet. Then in 2007 came a detection of what would become the biggest mystery in physics, something that could have been a game changer in the search for aliens.
My student showed me this signal that was so bright and apparently so far away that it was completely unlike anything we'd ever seen before.
Then we realized this is just impossible, unless a civilization is way more advanced than we are.
Scientist Duncan Lorimer and his team had found what we now call fast radio bursts. They're incredibly bright radio signals, so bright that they can't be coming from any naturally occurring phenomena on Earth. They have to be coming from outer space.
Quite frankly, it was unlike anything I'd ever seen before, yet it had all the hallmarks of a signal that was coming from deep space.
I did think that it could be a signal from an extraterrestrial civilization. We create signals like that on Earth, so it's not crazy to think that radio bursts could be created on another planet.
So it was a groundbreaking time for physicists, and with this new data from Lorimer, the burning question everyone still had was, are these alien signals? Now, the problem with the Lorimer burst was that it was just a one-off, and how do you prove a one-off is real and not just some noise or some random signal in your detector? Well, it helped when other scientists around the world started detecting signals just like it.
They were coming from all over the sky, and they were clearly real, so it was a breakthrough moment.
Now, although this seemed really exciting, it meant that there were probably much more likely explanations for what was going on.
We observe binary systems of two neutron stars that are in orbit around each other, and when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. When you look at the energetics of these events, you can easily explain the FRB energies with them. You can also explain the durations of the FRB pulses with the expected durations of these merger events. So it's quite a plausible explanation.
Now, neutron stars are some of the most energetic objects in the universe, second only to black holes, and you need something really energetic to produce a fast radio burst. Now, astronomers recently have discovered a fast radio burst coming from a magnetar in our own Milky Way galaxy. A magnetar is a special type of neutron star that has a very high magnetic field. And while this is really exciting that we finally might have an explanation, it means that aliens producing FRBs is becoming a lot less likely.
Now that fast radio bursts are real, it comes back to the point whether they could be caused by aliens. So if I were looking for a signal from an extraterrestrial civilization, I'd be looking for it coming from a single point in the sky. Here we have a population of sources all over the sky, which implies that the aliens are all over the place, all over the universe. That just seems highly unlikely to me.
So we're one step closer to solving the mystery of fast radio bursts, even though it's looking likely that they're not the alien signals that everyone was secretly hoping for. But as a scientist, I reckon never say never. We'll always keep observing the sky, and I think in our lifetimes, we've got a great chance of discovering alien life somewhere out there in the universe.
We have done a great deal of searching in the last 50 plus years, and we've learned that we're going to have to search perhaps 1 million stars on countless frequency channels before we have a good chance of success. If I had this to do all over, I would still do it. I'd in fact probably put more time into it because I've come to realize that's what's required to succeed. And to me, that time is not time wasted because the eventual discovery is of such importance that it justifies not just one human life being dedicated to succeeding, but many.
This weird creature might just be the best living explorer in the universe.
Took him into space, put him on a satellite, opened up the door, set him outside, exposed him to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation.
And they come back alive.
This is the tardigrade, often called the water bear, and you can probably guess why. And they might even hold clues as to whether life on Earth arrived from outer space.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth.
Could they even be the origin of life themselves? So what is a tardigrade? They're aquatic, microscopic animals, barely visible to the naked eye, as they're transparent and only about 1 millimeter long. They also love mossy conditions, which has earned tardigrades their adorable nickname, moss piglets. Aww.
Tardigrade means this Latin name, slow stepper. Tardi means slow, and grade, it refers to foot. You can start to see he's got long, thin filaments coming off his body, and some actual, more almost look like horns coming off his head that he uses in feeding.
So why are these moss piglets the ultimate space explorers? Well, despite being water-dwelling creatures, they have a special process of morphing or adapting to hostile surroundings, like radiation or freezing temperatures. By drying themselves out, they can cope with all kinds of nasty conditions.
As that sample jar starts to dry out, as that specimen starts to dry out, what's cool about these guys is they can survive that extreme desiccation, drying down to like a crispy little booger.
It's called a ton. They roll up into a special, tight ball essentially, like a roly-poly bug almost, and then go through a series of radical chemical changes in the cells in their bodies to deal with this loss of water.
Being in a ton form, tardigrades are as far from alive as you can be. But give them a splash of water and they spring back to life. What better place to test the robustness of a ton-state tardigrade than the freezing sprawls of Antarctica?
We extracted them from soils in Antarctica, shipped them back here frozen solid, and they've been frozen solid here at least -60 since 2012. Holy moly! It's mind-blowing, dude. It's basically the same community that I saw when I collected them in Antarctica. We put them in a tube, froze them, shipped them. 4 or 5 years later, we want to study them, right? Pull them out, we thawed them out. And now, what I'm seeing now looks almost exactly like what I saw when I was looking at them, like fresh in Antarctica.
So they can survive the most extreme conditions on Earth. But what about in space? Byron and his colleague Carl took them on a special outing to the International Space Station.
Took them into space, put them on a satellite, opened up the door, set them outside, exposed them to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation. And then when they brought them back to Earth, they did what you're seeing here. They dumped some water on them, see if they actually reanimate.
Voila. they take the water up, man, and they start, right? They swap it out, the molecules, and like a machine, man. You add the water to it, they take them up, cells start to do their thing again, and they come back alive. It always blows my, look, I'm an old fat dude, and I've looked at these 100 times, thousands of times, millions maybe. Man, well, and then when I actually look at them under the microscope every single time, I'm like, dang, that's cool, man.
Just like that, the mighty water bear enters tun state and navigates brutal conditions that would kill almost every other living thing. So if we know they can survive in space, and we know they survive on Earth, could it be possible that these space explorers travelled between the two, possibly even sparking life on Earth? When the Israeli space agency Space IL crashed their lunar lander Bereshit in April 2019, one scientist began to wonder, could the colony of tardigrades they had on board have survived? And could they survive a crash landing to Earth if they hitched a ride on a meteorite? Alejandro Traspas Muina of the University of Kent set about replicating the Bereshit crash and the kinds of pressures that this little batch of bears would have experienced by firing them out of a gun. Okay, so not quite a gun like that, more of a lab-based gas gun. Alejandro recreated the moon's conditions in a chamber and then fired the tardigrades into sand to recreate the impact that they would have had on that fateful day.
Knowing how fast the spacecraft from the Bereshit mission crashed, we thought, well, let's try different speeds up to 1 kilometer per second, which, if you think about it, if just to get it into a daily activity, just think you're in your car and your car starts going faster and faster and faster, up to 3,600 kilometers per hour. So this is how fast tardigrades were shot. So we started with 0.5, which they all survive, 100% survival, so that's great. We researchers happy, tardigrades happy, and we kept going. We went up to 0.7, and they again survived. Then we went up to 0.9, and unfortunately at these speeds tardigrades couldn't make it, which means they didn't survive the Bereshit mission.
But this isn't the end of tardigrades in space. Alejandro's studies continue. She and her team are testing whether they could survive in the water plumes or the icy surfaces of the moons of Saturn and Jupiter.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth. I do not believe life is unique to Earth.
So don't write off tardigrades just yet. They and other extremophiles could still provide the answer to the life we live today. The DART mission is designed to save Earth from an asteroid.
DART is our first planetary defense mission.
Defending against asteroids like this one, Bennu. We're bombarded by almost 50,000 kilograms of space rocks every day. Most are tiny and burn up in the atmosphere as shooting stars. But some bigger ones can cause real damage, like this meteor in Chelyabinsk, Russia in 2013, which exploded with the power of 13 Hiroshima bombs. And that was only 17 meters wide. By comparison, the asteroid that killed the dinosaurs was 10 to 15 kilometers wide. And now, there is another asteroid on its way. Bennu is about 0.5 kilometers wide, about as wide as the Empire State Building is tall. Between the years 2175 and 2199, there is a 1 in 2,700 chance of Bennu impacting Earth. Doesn't sound like much of a risk, but if it does hit, it will have the power of 80,000 Hiroshima bombs. But don't worry, NASA and the European Space Agency are on it. Enter DART, the Double Asteroid Redirection Test. Developed and led for NASA by Johns Hopkins University Applied Physics Laboratory, it does what it says on the tin, really. At least, that's the aim.
DART is a demonstration of the kinetic impact technique, just slamming a spacecraft into the asteroid.
Brilliant.
I'm Lindley Johnson. I am NASA's first ever planetary defense officer. This mission will demonstrate that humankind doesn't have to worry about going the way of the dinosaurs.
Why double?
It is called the double asteroid redirection test because we are targeting a binary asteroid system called Didymos, which means twins, and impacting the moon to change that moon's orbit around the larger asteroid. The impact affects an asteroid the size of Dimorphos, the moon of Didymos, 160 meters or so in size, the size of a small football stadium, would be an area of a small United States or a European nation. So it's important that we be able to protect life on Earth with this capability.
DART is set to hit Didymos in autumn 2022. We'll be able to measure some of the impact from Earth, but another spacecraft is heading that way. The European Space Agency's Hera will arrive around 4 years later to assess the outcome of DART's mission. But why go to so much trouble when Didymos isn't even at risk of hitting the Earth? Because Didymos isn't the only thing out there. There are over 20,000 asteroids close to the Earth, of which 1,200 are considered high risk. Thankfully, people like Richard Kowalski scour the night sky to find asteroids before they find us. They're known as the asteroid hunters.
As you can see on this screen is the sequence of 4 images that came from the telescope. These objects around the screen are not moving, so we know that they're stars, but this object in the center is moving, and thus we know that it's an asteroid. The importance of surveying for near-Earth asteroids is asteroid impact on the Earth is truly the only natural disaster that we can actually predict before it happens. The Earth has been hit in the past and will be hit again in the future. What we'd like to do is to be able to discover these objects before they hit the Earth.
Observations collected are all sent to the Minor Planet Center, and if they are asteroids that could come near the Earth and be a potential impact hazard, that information is sent to the Planetary Defense Coordination Office at NASA. If an asteroid is a more immediate threat of impact, I actually get a text notification on my smartphone. At NASA, we're kind of the Uber asteroid hunters, maybe is what you could say.
So what would happen if an asteroid did hit Earth? Well, we all know impacts leave craters, but what else happens? Because it's not just the collision itself that would cause devastation.
So for this experiment, we're going to fire this tiny 1/4-inch aluminum sphere at very high speeds, up around 5 kilometers per second. And then we'll see what type of crater it produces. So we use sand because it records the shock effects very clearly.
Pete Schultz uses super high-speed cameras to capture every detail of the impact and aftermath.
High voltage, the paddle is in, warning lights, and rolling.
The ball travels 15 times faster than the speed of sound. And like some asteroids would, incinerates on impact.
Oh, perfect, perfect, perfect. Now we're seeing the fireball come in. It's brighter than the sun and then kapow! It hits the surface, jeez. This whole region downrange would have been incinerated. It would have been incinerated just by this plasma, this exploding vapor plume engulfing everything. There would have been winds that would have been going so fast it could pick up houses and spread them hundreds of kilometers away. This would have been Armageddon.
So all eyes are on the DART mission. And there are a couple of other asteroid deflection ideas floating around too. Some of them are wild. Here are some of the top ones. 1. Nuke it. Very Hollywood and probably the first thing you thought of too. Great in theory, but could result in radioactive debris raining from the sky. Not ideal. 2. Gravity tractor. Sounds very space farming, doesn't it? The idea here is to fly a device next to an asteroid, so it slowly pulls it away from the Earth's path. This offers a lot of control, but it might not be effective for anything over 500 meters in diameter. 3. Paintballs. Yeah, you heard right, paintballs. Personally, my favorite suggestion. First, the act of shooting the asteroid would deflect it. And also, using white reflective paint means that the force of the sun's photons would theoretically push the asteroid even further off course. The downside? You'd need about 20 years' notice for it to work. So, we've got paintballs, tractors, and nukes, which might all seem like crazy ideas, but they're serious contenders. For now, though, it's all eyes on DART and its mission to save the world.